Hi, I'm Phil, and I'm continuing with electronic music, and I'm going to add LittleBits and a microbit computer to the Korg Volca Modular. So we looked at the details of that in the previous video, and I'm going to have a look at the latest project. So we'll just open up projects and LittleBits. And the one I'm interested in this time is, let's have a look at what it looks like on my desktop first. So we'll just move across, and we've got a couple of other photos we can show. So the total arrangement you can see on the photo here, and breaking that up, we've got a couple of boards for our for our LittleBits. So here's the Spectrum Analyser, and just under that we've got the in the middle we have our microbit computer on a LittleBits adapter. On the top arm we've got the keyboard, the LittleBits keyboard, and the pitch proximity switch. The other proximity switch for our Theremin is beneath that on the left, and that feeds into the lower port. And on the right, you can see that we've got the output CV LittleBit modules, and they're connected to the Korg Volca Modular. And this is what our keyboard and proximity switch looks like, and our CV output. Our microbit is connected to a LCD, so we can get extra data. And I'm using a splitter for the output on the Volca, so that I can put one into the Spectrum Analyser, and the other one will go to our donor portable speaker. So what's the objective here? Well, the idea is to explore pitch and gate control with the Volca Modular using CV. Now, remember that the Volca Modular is the only Volca that does not have a MIDI in control. So the only way we can actually use an external control or extend the number of sequences is to use the CV. And we're going to use the microbit for both pitch and gate, but it's also going to be used to provide a larger number of sequences. But in this program, I'll only have the same number, that is 16 steps in the sequence. So we can make a piano, that'll be mode 1. We can make a theremin, that'll be mode 2, and a microbit sequencer, and that's mode 3. And we're going to use notes with the MIDI notation. So if you look at that notation, we're going to use 60 to represent C in octave 5. Okay, so we're seeing our hardware. So let's just look at that in a little bit more detail. So we've got a Volca Modular, and in LittleBits, we've got the keyboard, 2 proximity detectors. We've got the microbit adapter, and we're using 2 CV modules, a splitter, and the number module is used as a voltmeter. And we're using the LED matrix to show the spectrum of the sounds that we're creating. We use up to 3 USB power units, and we're using 2 baseboards. We should change that to 2. And this is our overall arrangement. And we'll see that in a minute. We'll go and have a look at the hardware construction and how everything is patched up. And what we do with the Volca is that we want to connect the CV in to our oscillators and to the envelope function control. And here is our pitch. Here's our patches for the Volca Modular. So we take the two wires going into the carrier oscillator, and that's the black wire, and the purple wire goes into the envelope control for our gate. And the other modules are shown here. And we'll have a look at the software now. Let's have a look at the hardware construction. So we start off with the LittleBits microbit adapter. And while the microbit has many ports, this adapter is limited to 6 ports. And on the left, we have ports 2, 1, and 0. And these are inputs. And on the output, we have ports 13, 14, and 15. And it's not that flexible. That is, we have these ports are restricted on the left to input ports, and on the right, they're output ports. And the reason for this is that there's, on the LittleBit side, there's a 5.0 volt system, and the microbit is a 3.3 volt system. But despite that, we could still construct. We add our keyboard and our USB power supply, and we then add our proximity sensors, and that gives us our Theremin. So here we've got a keyboard and a Theremin arrangement with pitch and velocity control. And on the output, we've got 2 CV bits. And we finally can add our microbit to the slot. And that's the hardware construction for adding the microbit and LittleBits, and it will go to the modular. So we send our white 3.3 mono signal, and our red signal goes to our Volca. And I'm also adding the Kitronics view so that I can get extra data while I'm debugging the program. And I'm also adding an additional arm. This is a LittleBits audio spectrum. So with this, we start off with USB power. We have a microphone, and we then use the LittleBit split, and we add the matrix so that we can see the spectrum of our audio signal. And besides seeing it, we can hear the music, and we connect the audio connection to both the LittleBits microphone unit and also to the donor is connected to our Korg Volca Modular. So let's have a look at the software using Microsoft MakeCode for our CV control. The program's called CV Test 13, and this is the overall program, and we'll walk through it step by step. So on the left, we've got our startup routine. That whole column on the left is just for startup. Most of the in the next column, we've got the forever, and then we have a look at the buttons process for button A and button B. And on the right, we've got our functions for the sequencer. And under that, we've got the theremin and the keyboard. And on the extreme right, on the bottom, when we press the logo button, we can change the beats per minute. So let's have a look at that in detail. We'll just zoom up and go through the startup. So here's our startup program. And what we're doing here is setting a maximum of 3 modes, but the initial mode is number 3. And we look at the ambient voltage for our proximity center is going into P0. And we set up an array. This array is for our sequencer, and these numbers are all MIDI numbers. So we start off with middle C, and we can then assign those as elements in song 1. And we just initialize the other variables. So we get the length of that song, and the minimum MIDI note will be 48, and the maximum is 84. And we do a similar thing for the ADC, the minimum and maximum, and with the beats per minute, with a minimum and maximum. And we set up our LCD display with a large font, and we get the ambient voltage of our keyboard array. Now remember, on the LittleBit side, most of it is in analog, and we have to do the conversion. So in the process of forever, we show the mode and the current beat in beats per minute, and we then proceed to get the values of those analog readings from the keyboard and the proximity switch for our pitch and velocity. And depending on the mode, we then call up the function of keyboard, play theremin, and sequencer. And if we want to change our mode, we use button A. And if we want to reset everything, and including getting those ambient values again, we press button B. So to play the theremin, we just simply convert our theremin, our proximity for the pitch goes on to CV note, and that is then sent out to port 13, which is connected to the LittleBits CV module. And to play the keyboard, we get the CV note, and we then play it also on P15. But we do a bit of gate control here, and we only allow 1 second to play our note. And if we want to change the beats per minute, we can use the logo button, and we show that on the microbit LED array. So we now have our synthesizer in keyboard mode, which means that we can go around and press the keys on our piano and turn up the volume. And we get the notes on our Spectrum Analyser. So the actual voltmeters, the top one is our pitch and our gate. The second voltmeter is our gate voltmeter. And we can turn that off. So that's mode number 1. Now to go to the other modes, we go and press on A, and now we have theremin mode, and we've got 2. can actually stop that with the other gate control over here. And the third mode is sequencer mode. So what we do is go back to our microbit and put it onto mode 3, and it will play the notes. And you can see the pitch voltmeter is going up gradually. And that's our synthesizer, based on the Korg Modular, and it's using LittleBit electronics together with a microbit computer and a LittleBit microbit adapter. It's got a proximity switch for our pitch and another proximity switch for our velocity or gate control, and we've got a Spectrum Analyser and 2 CV outputs that go back to the Volca Modular, and we have a donor speaker, and that's it. So our overall results were that we were able to get the pitch from the LittleBits, and that could come from either the keyboard, the micro sequencer, or from the proximity sensors. And those pitch values are in volts, so we have to use an analog to digital converter on the microbit computer to convert those into a digital signal that we can process with our software. And we were able to get the CV gate control using the other proximity sensor. So combining those proximity sensors, we've created a Theremin musical instrument. So what we've done, we've got a keyboard, a Theremin, and a sequencer, all controlled by the one microbit computer. So overall, we achieved the results. So just to look at the references before we go. Okay, so if you're interested in this, you can see the Korg Modular on the Korg website, and plenty of videos on the Korg Modular. And there's a good series of tutorials by Tony Horgan on the Korg Modular. And if you look at the books, I recommend his book. And that's all for me on the making a musical instrument with the LittleBits modules, the microbit computer, and the Korg Modular. That's all from me. Bye from now.